What is up, you little dubs? My name is Mohawk, and yes, and today I am going to do another educational vid, guys. Yes, I am back with another educational vid, guys, and I hope you enjoyed the last video because that one, I enjoy that as well. So I'm back with a part 2 of Indices, and this one, we're gonna head on to zero index and negative indices. So it's a pretty interesting, complicated, but it's a pretty interesting and complicated topic, but it's gonna be fine for you because you got me as a teacher, right? So before we head on, I just want to review a quick thing from our old video, from our previous video, okay guys? So let's now talk about variables, because we didn't talk about variables last time, so now I'm going to talk about it now. Okay, so I'll give you a question, and then you can do it on your own. So I'll just give you a question straight away. So let's say AV cubed is multiplied by A squared V. Now, can you please check if you got it right, because you can pause the video if you want to, or if you don't want to, it's fine. I think this is an easy question for you guys. So if you're done pausing, and if you got the answer, I will explain the answer. Okay, so remember, you only have to multiply the same base. Not multiply the bases, but add the indices of the same base. So we got A and A. So this is essentially A1. So this is A1 times A to the power of 2. So what you need to do is literally just this, A1 plus 2. Because remember, if you multiply the same bases with different powers, you just have to add the powers, okay guys? And then, since it's in a multiplication form with this A and then V cubed, you can just put the V here, and you can just add, because this is also V1, so just V, and then to the power of 3 plus 1. So yeah, but we're not done yet, because we need to simplify further, okay? So this literally is A cubed V to the power of 4. Because you don't have to combine this, and you don't have to combine the, it is already combined, but you don't have to multiply, because it is already multiplied, the A and V. Alright, you just have to multiply this one, and that gives you this. Just A cubed, and then V to the power of 4. Alright, you don't have to do some extra smancy stuff, because that is not important, guys. So, now, I will give you an actual complex question for you to do, and this is just a review from all of our things we did last lesson, okay? All of our subtopics, okay? So here it is. This is the question, and I hope you can solve it by yourself. If not, that is okay. I will teach you, because this is very difficult. But let's see. YZ all squared. Okay, so 7. So I'll write it out because my handwriting is not that good. So it's 7y squared z in brackets all squared times 3yz squared, and the 7, and then the denominator is 7 brackets yz all squared. Okay, so that is that. Oops, sorry. Alright, so pause the video. You can solve it on your own. Alright? Okay. Alright, if you are back, I'll just delete this because I think you've already solved it. If you haven't, that's alright. Alright, so 49, because you have to square all the brackets. So this was this originally, 7y squared z squared. You have to consider that this is 7 to the power of 1. And if that's 7 to the power of 1, this outside power has to multiply by that power, and that gives 7 squared. 7 squared is 49. And then this outside power has to multiply by this power on y, which is 4. 2 times 2 is 4, so that's y 4, okay? And then this is z, So this is z to the power of 1 as well. So 2 times 1, yeah. 2 times 1 is 2, so it's z squared. So yep, so I'll write it out again. So it's 49 y to the power of 4 z squared. Okay, that is for the first variable for the numerator. Okay, but this one is just free yz squared. Yeah, just no brackets, no extra stuff you don't need to do, no extra procedures. It's just that. Okay, so it's just 49 y to the power of 4 z squared times free yz squared. Okay, don't have to simplify that yet because I need to write out the denominator. So denominator is 7y squared z squared. And because it's 7y squared z squared, because it's like this, that's y to the power 1, that's z to the power 1. So that's 2 times 1 is 2, and 2 times 1 is 2 again. And if you simplify that, it's just y squared z squared, because of our third index law we learned in our last video. So that is that. So what we need to do is now we need to simplify the numerator. So the numerator, so that's 49 y to the power 4 z squared times free y z squared. So 49 times free. So 49 times free is 147. And remember, you can multiply with, if the base is not the same in variables. Okay, so you can. Okay, guys, I'm technically right, but if you have to multiply different bases without any power, so like there are no powers in the bases, then you can multiply the bases. But if it's like 4 squared times 2 squared, you cannot multiply the bases. You cannot say 8 to the power 4 or 8 to the power 8 squared. You cannot do that. Okay, it's only without powers. Okay, only without powers. Okay, guys. And y to the power 4 times y to the power of 1, it's just y to the power of 4 plus 1, which is y to the power of 5. That's a 5. And then z squared times z squared is z to the power of 2 plus 2, which is z to the power of 4. Okay, guys, capisco? I think you got it. So it's 147 y to the power of 5 and z to the power of 4. So this is the numerator, 147 y to the power of 5 z to the power of 4. And it is over 7 y squared z squared. So what you need to do now is you need to divide these variables. Okay, guys? So remember, if we need to divide, we need to minus, we need to subtract the powers. Okay, so but for these constants, which is 147 and 7, we can just divide it by 7 both sides, because there's nothing really. You can just divide by 7 if that's the highest common factor. In this case, 7 is the highest common factor, so you can just do that. Okay, I mean lowest common multiple, if that's lowest common multiple. So 147 divided by 7 is 21. So now 7 is out of the equation. Okay, out of the expression. So z squared y to the power of 5 z to the power of 4. But now it still needs to be simplified, guys. You know why? Because y squared and z squared can be eliminated, because the powers on the numerator are higher than the powers on the denominator. So let me break it down. Okay, so it is originally 21 y to the power of 5 z to the power of 4 y squared z squared. So let's do the y's first. Okay, y 5 divided by y squared is just y power of 5 minus 2, which equals y to the power of 3. We got y done. That's crossed out. Y squared is crossed out. That's done. Now z to the power of 4 divided by z to the power of 2 equals z to the power of 4 minus 2, which equals z to the power z squared. And so z squared is also out. And we're left with... So, we are left with... this will take a while. Okay, y cubed z squared. That is your final answer, guys. This is your answer you've been looking for. So, the final answer is 21 y cubed z squared. And if you are still confused with this, I will just write it down in the comments below, and I'll help you, okay? So yeah, that's the answer, guys. If you're confused, yeah, just write it down in the comments, alright? Now, we can move on to our next topic, which is the zero index. And this is a really fun topic, I love this. So let's head on. Okay, so, if a to the power of 0, if a is to the power of 0, that will equal 1. But if a is 0, the answer is undefined. Answer is undefined, okay? I'll tell you why in just a second. So any number except for 0 to the power of 0 is 1. Okay, I'll show you, okay? So, 2 to the power of 5 is 32. 2 to the power of 4 is 16. 2 to the power of 3 is 8. 2 to the power of 2 is 4. 2 to the power of 1 is 2. 2 to the power of 0 is 1. Can you find the relationship between these numbers, these consecutive numbers, okay? Just find it. If you can, that's okay. Pause the video if you can't find it. Shove it. So, what is happening here? It's dividing by 2 all the time. So you can see 32 divided by 2 is 16, and that'll get us 2 to the power of 4. And if 5 divided by 2 equals 2 to the power of 4, because we're dividing by 2 from 2 to the power of 5, and that is 2 to the power of 4. If you can't see here, that's 2 to the power of 4, because 5 minus 1, 4, and that's 2 to the power of 4, okay? It works for everything. Divide by 2, so 16 divided by 2 is 8, 8 divided by 2 is 4, 4 divided by 2 is 2, and 2 divided by 2 is 1. That's how 2 to the power of 0 is 1, because look, divided by equals 2, 0, which equals 1. So yeah, that is it, alright? That is the explanation of why any number except for 0, oh, whoopsie, any number except for 0 is to the power of 1. Alright? It's even true for 3. So 3 to the power of 3 is 27. 3 to the power of 2 is 9. 3 to the power of 1 is 3. 3 to the power of 0 is 1. Divide by 3. Divide by 3. Divide by 3. It goes on and on and on, guys. It's for infinity. Okay. Now, I will give an example of a zero index question, and you guys just solve it, guys. All right, just try to solve it. Okay. So, if 3m or 4 times which is 0 times 4m 4 0. Can you please solve this, guys? Alright, just pause the video if you can. Alright, if you solved it. Alright. So, guys, alright, now, done. Okay, so, let's see here, guys. Let's try to solve this together. Okay, so, now there are a couple of index laws applied here. So, let's go step by step. 3. M 4 0. What is happening here? So, what you need to do, remember, anything in a bracket and it's to the power of something, you have to multiply the powers, okay? So, in this case, it's m to the power of 4 to the power of 0. So, m to the power of 4 in brackets, and it's to the power of 0. What you do is free m 4 times 0. Okay, guys? Free m 4 times 0. But, guys, what is that? That is, guys, that is just free m to the power of 0. And guys, free brackets m to the power of 0 is just free 1, which is just free times 1 is free. It's just free, guys. Nothing smancy, fancy, rancy right here. Alright, it's just free, okay? Let's do the second one. Okay, that's to the power of 0. So, 4m power 4, 0. Let's see. So, this is 1. So, 0 times 1 is 0. So, 4 to the power of 0 is, okay, I'll just write it out here. 3, 0. So, that's 0. Whoopsie. Okay. So, it's just 1 times 1, because 0 times 1 is 0. 0 times 4 is also 0. So 4 to the power of 0 is 1, and m to the power of 0 is also 1, okay? Which is, and it's in a multiplication form, so it's 1 times 1, which is just 1. It's just 1, guys. So look here. We got free here. Whoops. Got free there. And we got 1 here. So it's just free times 1, which is free. Guys, it's just free, guys. That is so simple. That's why I like this. That's why zero index is my favorite, okay? It's just, the answer is just free, okay, guys? It's that simple, okay? But now, we head on to negative indices, guys. This is where it gets, this is where it gets tricky, okay, guys? Okay, I'll teach you guys, okay? So 2 to the power of 3 equals 8. 2 to the power of 2 equals 4. 2 to the power of 1 equals 2. 2 to the power of 0 equals 1. And 2 to the power of negative 1 equals 1 over 2. Let's see what's going on. So this is obviously dividing by 2 all the time. Divide by 2. This is also divided by 2. And if that's divided by 2, this has to be divided by 2. And 1 divided by 2 is just 1 over 2, which is 0.5. So if you do this again, 2, negative 2, that'll just be 1 over 4, because 1 over 2 divided by 2 is 4. Wow, that's simple, guys. Oh my gosh, I did not know, guys. Okay, I'll give you an example with the variable, okay? You don't have to solve it, it's just like what I do at the start if I move on to another index law. Okay, so a negative m is equal to 1 over a to the power of m. That is true, because 2, negative 2 equals 1 over 2 over 2, 1 over 2 to the power of 2, which is 1 over 4. See, guys, that flippin' simple. So, let's do the last example for today, and we are done. Okay? So, let's see. Alright, so, let me just think. Alright. 4, and then got 4, and then we got m, negative 1, negative 2, over 16, m to the power of negative 2. Now, can you solve this expression just with all the exponents as positive? No, I don't want to see any negative exponents. Okay, guys, you just solve it. Oh, sorry, just solve it. That's true. You just solve it with positive indexes. Okay, positive exponents, not negative. I don't want to see any negative. All right, here we go. So just pause the video and let's go. Okay, so let's go. 4 brackets m to the power of negative 1 to the power of negative 2. So, let's see. Since m to the power of negative 1 is in brackets, not 4, we just concentrate on that, not 4, okay? Just leave 4 out for now, okay? So, negative 2 is just being applied to those brackets, okay? So, negative 2 times negative 1 is 2. So, it's just basically 4 times m to the power of 2, which equals 4m squared. Guys, 4m squared, wow. That was easy, right, guys? Well, better beware for this one. 16m negative. This is the denominator, guys. Okay, we got 16m to the power of negative 2. And remember, our law was m equals 1 over a to the power of m. So m in this case is 2. So let's see. 16 times 1 over m squared. Wow, 16 times 1 over m squared. What is that? Well, that's just 16 over m squared. And that's positive. There are no negatives present. So, it's just 4m squared divided by 16 over m squared. Yeah, we're done. No, we're not. We're not done, bros. Because 16 over m squared isn't a fraction, we cannot leave it in a fraction, guys. Okay, we need to sort this out, okay? So, 4m squared over 1, and it has to be divided by 16 over m squared. And remember, always the reciprocal here, okay? So, it's just 4m squared over 1. Okay, I have to, okay, whatever. 4m squared over 1 times m squared over 16. That is, just cross out the 4, because you have to divide by 4, because diagonally, just divide by 4. Remember your multiplication rules here. Just divide by 4 diagonally here. And so 4m squared divided by 4 is just m squared. 16 divided by 4 is 4. And then you get m squared times m squared over 4. So, m squared times n squared is m to the power of 4 over 4. That is that. That is it. That is the answer to your problem, guys. M to the power of 4 over 4 is your answer. No negative indices. Negative indices are absent right now. We only got positives. Okay, we're rolling with that, okay? That is it. It cannot be further simplified. There you go. That's your answer. Okay, guys. I hope you enjoyed this video, because I have, this video is too long right now recording. This is just 23 minutes long right now. Okay, I'll probably cut it down. But yeah, I hope you enjoyed, guys. And I'll see you later. Peace. Boop. See you later, guys. Hope you have a good day.